Right now, you're sitting in a building someone else made for you. You probably didn't think about it this morning. The walls, the ceiling, the floor beneath your feet. Someone poured concrete, someone welded steel, someone operated a crane that could lift 20 tons in a single swing. You flipped a switch and the lights came on. You turned a knob and clean water poured out. Every single thing around you was built with power tools, diesel engines, computer-aided design, and 2,000 years of accumulated engineering knowledge. Now rewind the clock 46 centuries. Stand in the desert outside what will one day become Cairo. There are no engines, no steel, no pulleys, no wheels in practical use, no written mathematics as you'd recognize it. The most advanced technology on Earth is a copper chisel and a whole lot of rope. And somehow, right here, a civilization is about to stack 6 million tons of limestone into a shape so precise that its base is level to within less than an inch across 13 acres. The Great Pyramid of Giza will hold the record as the tallest structure on Earth for nearly 4,000 years. So the question is brutally simple. With no machines, no iron, no modern math, how did ancient humans build something we'd still struggle to replicate today? Let's start with the part everyone gets wrong. You've probably heard the phrase slave labor thrown around. Maybe you picture thousands of miserable people being whipped under the sun, dragging stones until they collapsed. It's one of the most persistent myths in history, and it's almost certainly not true. In 1990, a tourist on horseback stumbled over a low mud brick wall about half a mile south of the Sphinx. That accident led archaeologist Mark Lehner and Egyptian archaeologist Zahi Hawass to uncover something extraordinary: an entire city. Not a prison camp, a city. They found bakeries that produced thousands of loaves of bread daily. They found breweries because, yes, pyramid builders drank beer. A thick, nutritious barley brew that was basically liquid bread. They found fish bones, cattle bones, evidence of regular meat consumption. They found sleeping quarters organized into modular blocks, like dormitories. They even found healed bones. Workers who'd broken arms or legs and received medical treatment, had their fractures set, and lived years afterward. Think about that for a second. You don't set a slave's broken bone and nurse him back to health over weeks. You replace him. These workers were fed better than most people in Egypt. Graffiti found inside the pyramids, yes, actual ancient graffiti, includes team names: Friends of Khufu, Drunkards of Menkaure. These weren't people being forced. They were organized into competitive crews, and they were proud enough to tag their work like a construction crew signing a beam. Pierre Tallet discovered papyri at Wadi al-Jarf in 2013. The oldest known papyri in existence, that detailed work logs, food rations, and boat operations for moving limestone blocks. It reads like a project manager's notebook. It's not the testimony of suffering, it's logistics. The real answer is stranger than slavery and more impressive. Egypt built the pyramids with something far more powerful than forced labor. It built them with the world's first organized state, a bureaucracy so effective it could feed, house, schedule, and rotate tens of thousands of workers across decades. The true miracle of the pyramids isn't stone, it's management. But okay, even if you've got motivated, well-fed workers, you still have a 2.3 million block problem. Each block in the Great Pyramid averages about 2.5 tons. Some of the granite blocks in the King's Chamber weigh 80 tons. That's the weight of a loaded Boeing 737. And those granite blocks didn't come from next door. They came from Aswan, over 500 miles to the south. Here's what nobody tells you about moving the stones. Water was the answer, and it was hiding in plain sight. Egypt didn't need wheels. It had something better: the Nile. Every year between June and September, the Nile flooded. The entire river valley became a navigable waterway that pushed right up to the edge of the Giza Plateau. Quarried granite blocks were loaded onto massive cedar boats, some over 100 feet long, like the Khufu ship discovered in a sealed pit beside the Great Pyramid in 1954, perfectly preserved for 45 centuries. Workers floated 80-ton stones hundreds of miles downstream, like packages on a conveyor belt. The river did the impossible work. Gravity and current moved what no human team could drag overland. And for the local limestone, the primary quarry sat just 300 meters south of the pyramid itself. Workers didn't haul most blocks across the desert. They cut them practically next door and moved them a distance you could walk in 3 minutes. A team from the University of Liverpool working with engineer Dick Perry has demonstrated that blocks sitting on wooden sledges could be dragged across sand with shocking ease if you pour water in front of the sledge first. Wet sand reduces friction by nearly 50%. A wall painting in the tomb of Jehutihotep, dating to around 1900 BCE, actually shows this happening. A man standing at the front of a sledge, pouring water onto the sand while a massive statue is dragged behind him. The evidence was literally painted on a wall for 4,000 years. We just didn't understand what we were looking at. Now here's where your brain should start hurting a little. Getting blocks to the base of the pyramid is one thing. Getting them 481 feet into the sky is something else entirely, and honestly, this is the part where even experts start arguing. The most widely respected theory comes from French architect Jean-Pierre Houdin, who proposed in 2007 that the Great Pyramid was built using an internal ramp. Not an external ramp spiraling up the outside. That would require a ramp almost as massive as the pyramid itself and would block surveyors from checking the angles as they built. Instead, Houdin believes workers constructed a gently sloping internal corkscrew ramp embedded within the structure, turning at each corner, rising through the body of the pyramid. Microgravimetry scans, basically density imaging of the pyramid's interior, conducted by the French team Huy and Bouy, showed a spiral-shaped anomaly of lower density winding up through the structure. It's not proof, but it's tantalizing. Here's the part nobody talks about. Whatever ramp system they used, the bottom 2/3 of the pyramid contains roughly 90% of the total stone volume. The truly massive hauling happened close to the ground. By the time workers reached the upper third, the blocks were smaller, the distances were shorter, and the workforce needed was a fraction of what it was at the base. The pyramid essentially gets easier to build as it gets harder to reach. That's not an accident, that's design. And all of this assumes you can actually cut stone with precision in the first place, which brings us to the tools, or more accurately, the embarrassing simplicity of the tools. The workers at Giza used copper chisels, dolerite pounders, and wooden wedges. That's mostly it. Copper is soft. It can't cut granite, so for granite blocks, workers used dolerite, a stone harder than granite itself, and literally pounded grooves into the rock face by smashing one stone against another, inch by inch. Experimental archaeologist Dennis Stocks spent years at Aswan replicating this process and proved it worked, but slowly. Cutting a single granite block could take weeks of continuous pounding by rotating teams. For the softer limestone, the process was faster but no less clever. Workers carved channels around a block using copper tools, then hammered dry wooden wedges into the base. Then they soaked the wedges with water. Wood expands when wet. The pressure cracked the limestone along a clean line, freeing the block from the bedrock like popping an ice cube from a tray. No dynamite. No diamond saws, just wood, water, and patience, measured in generations. And that patience is the part that changes everything once you understand the scale of time involved. The Great Pyramid took roughly 20 years to build. Pharaoh Khufu began planning it the moment he took the throne around 2580 BCE. He didn't see it as a construction project. He saw it as the organizing purpose of his entire civilization. During flood season, when farmers couldn't work their fields because the Nile had swallowed the farmland, the state called them to Giza. It fed them, housed them, organized them into teams of 20, grouped those teams into crews of 200, and rotated them in and out across months. Some workers were permanent skilled specialists, the stonecutters, the surveyors, the boat captains. Others were seasonal laborers fulfilling a kind of national service, a tax paid in sweat instead of grain. At peak construction, the workforce may have reached 20 to 30,000 people. Not the hundreds of thousands Herodotus claimed. He was writing 2,000 years after the fact and was basically repeating tour guide stories. The actual logistics, reconstructed from Lehner's excavation of the workers' village and Talat's Wadi al-Jarf papyri, suggest a tightly controlled operation closer to a modern megaproject than a chaotic human wave effort. Here's what doesn't make sense until you think about it. 20 years sounds like a long time, but to place 2.3 million blocks in 20 years, you need to place roughly 340 blocks per day, every single day, for 2 decades. That's 1 block every 2 minutes during a 10-hour working day. That rhythm, that relentless, almost musical precision, is what separates the pyramids from every other ancient monument. It's not that they had a secret, it's that they had a system. A system so well-oiled, so deeply practiced, that an entire civilization moved like a single organism toward one shared geometric point in the sky. And now step back, way back. Because here's what the pyramids really are, underneath all the stone and engineering and logistics. They're proof of something about human beings that we keep forgetting. We are not primarily tool users, we are primarily cooperators. Every great thing our species has ever built, from Giza to the International Space Station, was not built because someone invented a clever machine. It was built because thousands of people agreed to show up, day after day, and do one small piece of something none of them would live to fully understand. The workers who dragged limestone in the first year of construction never saw the capstone placed in the 20th. The surveyors who aligned the base to true north within 3/60ths of a degree, a feat confirmed by Flinders Petrie's meticulous survey in 1882, did their work in the flat dust of the plateau, never knowing how their precision would look from a mile away. Each person held one piece of the blueprint, no one held all of it, and yet it came together, block after block, year after year, into something that has outlasted every empire, every language, every religion that has existed since. Winter didn't threaten the pyramid builders. The desert did. It came at them with heat that could kill a man in hours, with soft sand that swallowed everything, with copper tools that bent against hard stone, and with a timeline that stretched beyond any single human life. And they answered every one. They answered the heat with flood season scheduling and beer rations. They answered the sand with water poured onto sledge paths. They answered soft copper with harder stone. And they answered the impossible timeline by building a society where one generation's labor was another generation's inheritance. So tonight, when you walk into your building, the one someone else made for you, with its electric lights and running water and concrete walls, reach out and touch the wall for a second. Feel how smooth it is. Feel how permanent it feels. Now imagine your bare hand against sun-scorched limestone 4,500 years ago, knowing that the block you're dragging into place will still be standing when every person you've ever loved has been dust for 40 centuries. That's not a monument to a pharaoh. That's a monument to what ordinary people can do when they decide that something matters more than one lifetime.